Choosing the right materials for your model and consequently your product is an instrumental part of product development. Thus, it is important to be able to experiment with different materials of construction and see how they measure up to your design and performance requirements. For all Comsol Multiphysics versions 5.0 and later, you can utilize material sweeps to easily change the materials of different parts of your model, and then see how these changes affect your results. Here you can see we have the bus bar tutorial model opened up, and let's say we wanted to test different materials for the bolts of the bus bar. Instead of having to resolve our simulation for each material separately, we can automate this process by performing a material sweep. To start off, we go under our local materials node, right-click, and then select switch to add the material switch node. And this is going to enable us to switch between the different materials that we specify. And this switch function can also be specified globally. So under the settings, you can see the geometric entity selection, and this is where we would choose the parts of the geometry the switch would be applied to. So since it's the bolts, we can start selecting those and adding them, but you can see that there is already a selection for the bolts within the bus bar, so I can go ahead and select that, and all of the bolts have been specified. You'll also notice under the material content section a list of the properties required by the software to solve the model, and this list is populated based on the physics that we include in our simulation. So now that we've added the switch, we can go ahead and add the materials we want to switch between. So let's say the first material we want to include is aluminum. We select that, and then next to the Add to Component button is the drop-down arrow. We click that, and then we select Add to Switch 1. And we do this with any material that we want to include in the material switch node. So let's also include steel and titanium as well. Since it was already here in the materials node, we can drag and then drop it into the switch. So now that we've added the switch, we can go to the Study tab and we can click the Material Sweep button to add the sweep. So the Material Sweep is going to sweep over the materials we specified under our switch node. For all Comsol Multiphysics versions 5.0 and later, this is a new parametric study that is available. So in the Material Sweep window under Study Settings, we can click the Add button to add the material switch. And under our Cases column, we can choose to sweep over all the materials that we specified under the Material Switch node. Or we can also select User Defined, where we define the list of materials to sweep over using positive integers. So let's say here you can see we have a range that includes all of the materials, but let's say we wanted to only include the first, second, and third materials. We could change the case number simply to 1, 2, and 3. So the case numbers always refer to your materials in the order that they appear from the top down under the switch node. So case number 1 is always the first material under the switch node. Case number 2 is the second material from the top. 3 is the third, and so on. I'm going to select all to include all of the materials in this sweep, and you can also plot the results while the model is solving. Here we want to select default to plot one of the default plots of the model, which is based on the physics involved. The other plot group options listed here are from the stationary study solved when we opened this tutorial model up. With everything all set up, we can now click Compute. You can see here in the graphics window, the results plot is updating, showing the solution for each material. Now that our model has solved, we can go under the results. Let's select the temperature node. And you can see that we can choose between the different materials for the bus bar and then plot those results to compare them. And you can see from the differences in these results alone that changing the materials for a model can really give us some great insight as to how a material will perform.